An important component of established factory planning methods is the ideal layout. In practice, the term is often not even known. So the question is, what is an ideal layout and how is it used to save a lot of money? So what do we mean by an ideal layout? In reality, there are many restrictions. They make layout planning seemingly complicated because so much has to be taken into account. But this is a misconception. Restrictions limit the number of possible solutions, and they often lead to rigid thinking patterns and biased planning solutions. Ideal layout planning is about breaking free from spatial or technical restrictions and rediscovering what is feasible. This often leads to significantly better solutions that were not thought of before. Let's take a look at a simple example of how we build an ideal layout and how we transform it into reality. The starting point in the example is an existing solution. First, we remove all the restrictions shown previously and convert the existing solution into a simple block layout. Then, we visualize the material flows to take into account the relationships between the block layout objects. In the video description, you can find information on how to build block layouts with material flows. If you want to see more on this topic, please subscribe to our channel. The next step is to arrange the blocks ideally. This is where creativity is called for. It is significantly promoted by the absence of restrictions. Heuristics for optimization can help to find good solutions. Here, we see a procedure that shows an arrangement priority for a network structure. The objects with high priority are strongly integrated into the material flow. Objects with low priority have only weak material flow connections. The idea of this procedure is to arrange the objects with high priority centrally first, and then to place objects with low priority further outside. This should lead to good planning solutions. That is more of a theoretical explanation. Practically, of course, you do not have to work with the triangular grid. So let's take another look at it. We start with the highest priority objects and arrange them as close as possible, taking into account the material flow connections. Here, we can also create variants. As a result, we get our ideal layout. Next, we further develop the ideal into the real layout. How do we do that? We reintroduce all restrictions step by step. The first important restrictions are the transport paths. We simply develop our block layout, taking the transport routes into account. When we do this, we should keep the idea, or rather the basic structure, of the ideal layout as much as possible. As a result, we get a block layout including transport routes. After that, we add all other restrictions and layout objects, such as the building and the operating equipment. If necessary, we will have to change the block layout slightly, but these changes will probably not be serious. As a result, we get the real layout. The idea of the ideal layout is still included. The investment in the example is much lower than originally assumed. The solution is much better than all other solutions found before considering the restrictions. In this example, it was worth thinking outside the box. Perhaps you can do the same in your factory.